Hello everyone, my name is Hemu and today we are going to discuss packet flow in Palo Alto Firewall, or the best term for this statement is life of a packet inside the Palo Alto Firewall, means how Palo Alto Firewall going to do the packet processing. Okay, so before going into this particular explanation, let me just draw a couple of diagrams and let me show you how the things are happening. Okay. So let's suppose I have a diagram here. I'm just going with the very simple diagram, guys. So let's suppose I just have a one Palo Alto, one PC here, having IP address 10.1.1.70. Then I have a firewall here. This is my Palo Alto firewall, and this firewall have a one more interface here, Ethernet 1x3. This is Ethernet 1x1. This is my inside interface, and this is my DMZ interface. And here I have one of the server. Let's suppose this is the DMZ server 1, and that server having IP address 10.2.2.102, and this server is hosting the service on TCP port 80. Very simple setup. Okay, now what used to happen, I have this type of setup. Now let's suppose I have initiated some of the traffic from this PC towards that particular server, and I have a firewall in between. Now, as we have seen yesterday, the very first packet which is initiated by this particular PC towards the DMZ server is your TCP SYN. Right? TCP SYN received by the firewall. And when this firewall receives this TCP SYN, what it generally do? And this is the thing which we are going to discuss in throughout this particular session. So guys, when this firewall receive this particular TCP SYN request, what it will do? It will start processing this particular packet according to the life of a packet inside the Palo Alto. Means what it will do? It will start processing this packet against ingress stage. Then it will do the flow lookup. Then your slow path, fast path, app ID, content ID, then the egress stage. So these are the 7 stages inside your Palo Alto firewall, and this firewall going to send this particular packet against all these particular stages. Okay, now, so if you want to see all these stages, you can see here we have received the packet inside the Palo Alto firewall, and it has started processing the packet at ingress stage. Once ingress stage will complete, it will do the flow lookup, right? Then your slow path, then fast path. Fast path will start from here, then your app ID, then content ID, and end of the day, it will go towards the egress stage. So these are the stages available inside your Palo Alto firewall. So guys, now what we will do, now I will try to explain the working of each and every stage in detail. Okay. So this block diagram everyone know, right? Yesterday also we have discussed, like we have an interface stack. These interface has a connectivity with one of the chip called Marvel or Petra chip, and this particular chip has a further connectivity with your Liger or Tiger chip, which is your network processor, or it is also a session offloader. Then we have a Octeon chip, which is your data plane CPU. Then we have a Ocelot or Jaguar chip. Ocelot I have not mentioned because it's just a very old name. Okay, old chip. So nowadays we don't have Ocelot, so they are just using the Jaguar chip, which is a signature match processor or pattern matching processor. This is the block diagram, or you can say this is the data path of your Palo Alto firewall when it will receive the packet. Okay, now Palo Alto firewall have around 7 stages. These are the stages: ingress stage, session lookup or flow lookup, then slow path, which is also known as session setup stage, then fast path, or layer 2 to layer 4 security processing, then app ID, then content ID, and after that we have a forwarding stage, right? Now let's try to understand the same thing in detail. So I was looking for one diagram here. Just give me 1 second. Now let's try to understand what happens in the ingress stage, guys, when your PaloAlto 5 receive a packet. So generally what used to happen when Firewall receive a packet here, so if I will draw the packet here, like what is the content available in the packet. So if I will draw this packet content here, so now guys tell me what is the source IP address in this particular packet. 10.1.1.70, right? Then we have a destination IP address 10.2.2.101, or yeah, like 102. Source IP, destination IP, then we have a source port, any random port 3050, let's say it has pick. Then we have a destination port, and destination port here is 80. This is the packet content in this particular packet. Apart from this content, what is the other thing this particular packet will be having, right? This packet will also have some layer 2 data, which includes the source MAC address and the, I can say destination MAC means MAC address of your firewall Ethernet 1x1 interface, because this is the default gateway, right? L3 information, source IP address, destination IP address, and the layer 3 protocol number. Then we have a layer 4 information, which have your source port and destination port, and after that it has some layer 7 information, which is like it is a TCP SYN. So layer 7 information is 0 here. We don't have anything. Now, so guys, what used to happen when this packet received by the firewall on Ethernet 1x1 interface? So what it will do, it will basically first convert, because this packet he will receive in the form of 0 and 1, right? 0 1 1 0 0 0, right? It will receive this type of electronic signals here. So what it will do, now when this signal received into this particular port, now there is a chip called Marvel chip, a Petra chip, or your switch fabric. What it will do, it will convert these particular 0 and 1 in the form of your layer 2, layer 3, right? In the form of your frame. So then Ethernet, then your layer 3 header, like which is your IP header, then your layer 4 header, which is your TCP or UDP header, right? Then the layer 7 data. It will convert all these things. So this is the very first thing which is performed by the firewall, and this particular task done by the chip called Marvel chip. Now, once it will basically, that packet is constructed, so what will happen now, it will start the ingress stage processing. Okay, what it will do, it will start the ingress stage processing. Now let's try to understand what are the things it will do in the ingress stage basically. So in your ingress stage, when it will receive this particular packet, what it will do, it will start the packet ingress process. What it will do, it will extract your layer 2 information, layer 3 information, and layer 4 information from the packet. Means now my firewall get the source MAC address, destination MAC address, source IP, destination IP, and the source port detail, destination port detail, and also your layer 3 protocol number, right? This detail it has extracted from the packet. And now guys, tell me one thing, because we know this packet is received, or my firewall know he has received the packet on Ethernet 1x1 interface. So this interface become the ingress interface, right? And because Ethernet 1x1 interface is a part of inside zone, right? So which means firewall also get the ingress interface details and also get the source zone detail. This particular information it will get from the packet in your ingress stage processing. Sometime what used to happen, guys, I hope everyone know the fragmentation. I'm expecting everyone know the fragmentation, guys. What is this fragmentation basically? Or let me go one more thing. Let me open one more whiteboard here. If it is on a sync. Not syncing. Okay, cool. So what used to happen? What do you mean by the fragmentation, guys? Fragmentation means, let's suppose we have received a packet in big size. So guys, what is the default MTU value in your Ethernet ports? What is the default MTU value in your Ethernet ports? In most of the time 1500. Then what is the maximum segment size, guys? What is the maximum segment size if we have a default MTU which is 1500? 1460, because the minimum size of your IP header is 20 and minimum size of your TCP or your TCP header is 20. So we can reduce the 40 bytes and this is the maximum segment size. Now what happens? Let's say we have this PC here and let's say we have a router here and we have a server here. Let's suppose from this PC I have initiated a packet with 4000 bytes. This is F0 by 0, this is F0 by 1. So now guys, when this server or when this router, when he received this particular packet here, because let's suppose on this PC, on this interface, we have a MTU value which is 1500. Now guys, can this PC able to forward these many bytes through this particular port? No. What it will do, it will apply the fragmentation. In fragmentation, what it will do, it will basically create a fragments of this particular packet. Let's suppose you have created 3 fragments, F1, F2 and F3. So what used to happen when my firewall or when this router received these fragments to read the entire packet, because entire packet is 4000 bytes, what it will do, it needs to assemble these particular fragments and will create an entire packet of 4000 bytes. That is the fragmentation. And the assemble, when my firewall or when this router is doing the assembly of this fragmentation, which is known as fragment assembly, and this is the thing which it will perform in the ingress stage here. In the ingress stage, what it will do, it will do the fragment assembly, fragment reassembly if required means. And when this task needs to be done in the firewall, when we receive the fragmented packets. Okay, apart from this thing, guys, now what used to happen, once all these tasks has been completed, now my packet moved towards the next check. Now what it will do, this check means is known as a ingress process error. Ingress process error means what it will do, now my firewall check the layer 2 header. My firewall going to check layer 3 header, which is IPv4 header. It will going to check layer 3, which is your TCP header. Means these particular Ethernet header frame, these headers are formed correctly or not. Guys, tell me one thing. Let's suppose by using TCP, we are sending first packet. Can this first packet have the SYN flag equals to 1 and your FIN flag equals to 1 on the first packet, or the reset flag 1? No. This is a invalid combination of your flags. So it will check these type of errors. It will perform the cyclic redundancy checks, like a checksum. It will do the checksum checks as well, like whatever packet we have received, these packets are formed correctly or not according to the OSI model or according to the TCP/IP model, like the application who has basically sending this particular traffic is following that particular model or not, right? If there is any problem, if we have received any misconfigured packets or any invalid combination of anything with these particular header fields, what it will do, it will discard that packet right away. And guys, if he is discarding any packet in your ingress stage, you will not get any type of logs on the firewall. So if your packet is dropped by the firewall at the ingress stage, you are not going to see any type of logs. Just remember. So let's suppose if somebody is doing the troubleshooting and you are checking the traffic logs in the monitor tab of the firewall, and if you are not able to see any logs, it does not means your firewall is not blocking the traffic. Maybe your packet is dropping at the ingress stage. Okay. No. Once this part is done, now what it will do, there is a one more very important check it will perform, which is a DOS block table check. So guys, in your PaloAlto firewall, we have two things. We have a zone protection and we have a DOS protection. We have a zone protection field and we have a DOS protection. And guys, what these particular two things do in the PaloAlto firewall means you can able to apply the protection in your zones. You can able to configure the DOS protection. You can able to configure your security policy to protect us from the DDoS attack. So let's suppose somebody has launched the TCP SYN flood attack, or somebody has launched the UDP flood attack, or ICMP flood attack, or other IP flood attack, or somebody has doing the IP spoofing. And if you have configured zone protection or DOS protection, in that case, what it will do, let's suppose if there is any attack is going on, in that case, what it will do, my firewall going to restrict that particular communication. It will block that communication. It will put the details into the DOS block table. And let's suppose your IP address, whatever packet we have received, if that particular packet details is available in the DOS block table, which means this is some type of attacker, or maybe somebody is trying to launch some type of attack. If IP is a part of DOS block table, it will discard that packet right away. And this particular thing also you will not get in your logs. And after that, if DOS block table allow the traffic, then it will check firewall inspection applicable or not. So guys, this particular thing here, firewall inspection applicable or not, no means now firewall send this packet toward the egress stage. If yes, and generally guys, this particular feature is applied for the tap mode only. Because in tap mode deployment, we can configure a firewall in IDS mode. We cannot able to enforce, or we cannot able to block any traffic. So this particular, so in tap mode, we have a no here. And directly your packet used to go in the egress stage. Generally, otherwise for all type of deployment, we have a yes option, which yes option is applicable. And now it will check the packets against the IPsec, like the traffic which we have received is if it belongs to the IPsec VPN, or it belongs to SHS, or it belongs to SSL, or it belongs to GRE. Mean now it will try to, whatever packet we have received will check like if this traffic belongs to IPsec VPN. So guys, if you are aware about the basic of IPsec, don't worry, I'm going to discuss this in detail. So in IPsec VPN, what used to happen, packet starting from layer 2 to layer 7, this particular information is encrypted and hashed, and this particular information is encapsulated inside the ESP header. Just remember. So what used to happen now in case of IPsec ESP, what it will do, first they will do the decapsulation, means they will try to get this particular actual layer 3 to layer 7 information, and after that they will basically do the decryption, like they will check the hash, then they will decrypt it, and they will do the decapsulation. Means First, when they receive a ESP packet, they will check the hash to validate the integrity. Then they will apply the decryption, so they will get the actual IP details, and they will do the decapsulation to basically take out this particular information, the actual IP packet. And after that, this information they will give again to your ingress stage for the further processing, because the actual information is available here. In case of SSL VPN traffic, because in case of SSL, guys, your information is encapsulated by the TLS, transport layer security protocol. Means in case of SSL, only layer 7 information is encapsulated. So what they will do, they will check the hash and they will decrypt it. Here decapsulation is not done because we are not using any type of header for the hiding the information. Okay, here in TLS or in case of SSL, we just use the transport layer security, which is also application layer protocol. ESP is a layer 3 protocol, just remember. Okay. Now they will check the hash and they will decrypt it. Once they will get the actual information, they will put this information again for the ingress packet processing. In case of GRE, they will perform the hash, decapsulate it, and they will put the information here. Now for the same thing, they apply to the SHS as well, because in SHS also information is encrypted, right? So they will decrypt it and they will basically put that information again in the ingress packet processing. If yes, otherwise they will move further and now they will start the flow lookup. So now flow lookup I will discuss in some time. Now let's try to see here. So this is the bit old diagram. In this diagram, there is a like DOS block table field is missing, right? So there is a couple of fields are missing. So that is the reason I was not referring this one. So we have received the packet. Now they have started the extraction, right? They will do the ingress interface lookup or zone lookup. They will do the IP fragment reassembly, check the ingress errors, right? Firewall inspection applicable, yes or no? If yes, then they will check for the IPsec related traffic or SSL related traffic or GR related traffic, and they will do the tunnel decapsulation, decryption and all. Then they will put the packet again into the ingress stage processing. And after that, packet move towards the flow lookup. Now how they will start the ingress stage? So in ingress stage, we receive a packet from network interface. Now firewall start parsing the packet and determines whether given packet is subject for the firewall inspection or not. If packet is subject to firewall inspection, then continue with the firewall session lookup and enter security processing stage, otherwise forward the packet. Packet may be discarded due to protocol violation. Means now this thing comes into your error check stage. Means if there is any protocol violation is there in the packet, then this type of packet dropped by the firewall. Firewall attack prevention features may discard packet without configurable option, because those packet would be eventually discarded by end host. This thing is something like a DOS block table. Now how they used to perform the parsing? So what it will do, when they receive a packet, they start parsing the L2 information, L3 information and L4 information. This information has been extracted. They do the ingress interface lookup and zone lookup. Now how they will do the L2 parsing? So in layer 2, generally we have a frame, right? So frame is parsed and the PAN-OS, your PaloAlto operating system, extract the source MAC address and the destination MAC address from the packet. Packet processing start with layer 2 header of the packet received from the interface. Means your parsing will be started from the layer 2 onwards, just remember. And guys, when they will in the ingress state, they will check the ingress port. Let's suppose if sometime we used to configure the sub interfaces, or if we can also allow to configure the VLAN in your firewall, right? In that case, they will also check the VLAN tag as well, like 802.1q tag, and the destination MAC address are used as a key to look up the ingress logical interface. Means what they used to do, let's suppose we have received the VLAN related traffic. In that case, what it will do, how they will do the lookup, they use the destination address as a key to just perform the ingress logical interface. What is the like logical interface we have, or we have received the packet, right? If interface is not found, the packet is discarded, and the hardware interface counter, which is receive error, and the global counter, which is flow receive dot one q tag error, will be decremented. Now how you can able to check these particular things, right? So now let me just take the access of my firewall, so at least I just show you the commands. I'll go here. So guys, if you want to see any of this counter, like we have a counter named flow receive dot one q error, right? You can copy this counter, and there is a one command in your PaloAlto firewall is global so counter global. You can put match, and you can just copy this value, and this is the counter which will be incremented that time. So if there is any problem, you can just always try to look for this particular counter. Even though if you can also basically use the same command, if you will run, we have around 250 plus counters in your PaloAlto firewall, like packet receive counter, right? There is a hell lot of counters will be available. All counters is not showing right now because when we as we enable the features, we will able to see these counters detail, right? This is the counter flow receive dot one q tag error, right? And apart from this, if you can also able to run this command, control C. So interface ethernet, let's go one by one to check the details at the interface level as well. So this is the command which we generally check for that details. If there is any errors, forwarding errors, no route, like you will get hell lot of things here. If there is a IP spoofing is happening, you will see this counter is increasing, and we will launch these attacks. That's not a problem. I launch these type of attacks as well, guys. Okay, in your sessions, in your future sessions. No, let's go back here. Now, guys, let's try to understand how it will do the layer 3 parsing. So in layer 3, what they used to do, it will try to parse your IP header. What it will used to do, it will try to parse your IP header, because at layer 3, what we have IPv4 and we have IPv6, right? So now let's try to understand what IP header has been parsed, and PANOS extract the source IP address and destination IP address. Let me show you how they will do the extraction, guys. Just for, so like this is the TCP SYN packet processing. So what packet received at the ingress stage? Now in ingress stage, what they will try to start extracting like this. They've extracted your source MAC address, destination MAC address, and type in IP header. They will extract source IP, destination IP, layer 3 protocol number, version detail, IP header, TOS field, length, ID, fragment offset, TTL value, and checksum. So it will start doing the extraction in this particular way. Okay. Don't worry, by end of all these sessions, guys, you can able to extract these packets as well. That's not a problem. But you have to be with me for the sessions. Okay. IPv4, a packet can be discarded for any of the following reasons. So guys, now what are the commonly used, like what are the common regions your PaloAlto firewall or your PANOS will discard your IPv4 packets? So the very first reason is mismatch ether type of IP version. Means if there is a like a mismatch with the ether type of IP version, your packet has been dropped. Let's suppose in our interface, we or in our organization, we are just using IPv4, and let's suppose in the IPv header we got the packet for IPv6, which is a problem. So in such kind of cases, my firewall going to discard these particular packets. Just remember. Okay. Truncated IP header. Let's suppose in IP header we have some fixed fields, right? Let's suppose if these particular fields has been modified, or let's suppose somebody has modified these particular fields. In that case also, in this particular situation also, your packet has been discarded by the firewall. Means let's suppose somebody has removed the TTL field from this IP header, means truncated. Then we have a IP protocol. Let's suppose we are receiving the packet with the IP protocol number 0, means this is the layer 3 protocol number 0. These type of packets is also discarded by the PaloAlto firewall. Let's suppose we have received a packet with TTL 0. In that case also your firewall drop the packet. Let's suppose your source IP address equals to destination IP address, means source IP and destination IP address is same. So if this is a case, then PaloAlto consider this as a land attack. It will consider this as a land attack and will discard this type of packets as well. Then we have a ping of death, marginal IP address, right? These type of packet is also discarded by the PaloAlto firewall. In case of IPsec, like mismatch, ether type or IP versions, truncated IP header, truncated IP packets, jumbo gram extension, truncated extension field. So these type of packet is also dropped by the PaloAlto firewall. Now let's try to see how it will do the packet parsing for your layer 4 packets. So generally at layer 4, the most commonly used protocols is your TCP, UDP, ESP, GRE, ICMP, and there's a one more protocol called SIP. These are the commonly used protocols at your layer 4. So in case of TCP, what was the reason my firewall going to discard the packet? Means the very first reason TCP header is truncated, means let's suppose some of the fields from the TCP header has been deleted or has been modified. So such type of packet will be also discarded. Your data offset field is less than 5. In that case, also your packet has been discarded. Checksum error, if there is any checksum error, in case of TCP, your packet is discarded. Let's suppose we have a port value which is 0. In that case also, your packet has been discarded. Or if we have an invalid combination of TCP flag, means like a SYN flag equals to 1 and we have a FIN flag equals to 1. This is an invalid combination, right? In that particular situation also, your packet has been dropped by the PaloAlto firewall. And guys, at your TCP, the data format according to TCP IP and OSI model is segments. Here we have a segments. Okay. Now let's try to see for UDP. The packet is discarded due to following reasons, like UDP header is truncated, UDP payload is truncated, UDP buffer length less than UDP length fields, or there is some checksum error. In that case, your packet has been discarded by the PaloAlto firewall. Now let's move further. IP fragment reassembly if required. So IP fragments will be parsed and reassembled by the defragmentation process. So in PaloAlto, we have a defragmentation process which will do the IP fragment reassembly and fed back to the parser. Parsing will be continued with the layer 3 IP header. Means in case of fragments, first they will form the entire IP header and after that only they will start doing the parsing. A fragment may be discarded due to teardrop attack or the overlapping fragments. Means let's suppose somebody has created a couple of copies of your fragments, means they have some overlapping information. In that case, your firewall going to drop the packet and will consider this as a teardrop attack. If one of the fragments are missing, means let's suppose one of the device did the fragmentation and he has did with the 4 fragments, and let's say we have lost one of the fragment out of 4. In that case also, your fragmentation, in that situation also, firewall going to drop that particular packet because he will not able to construct the packets properly. Then ingress processing error. Then we have a DOS block table. So guys, DOS block table will drop the packet as discussed in case of zone protection or in case of DOS protection. If your zone protection or DOS protection policy has been triggered due to any type of attacks like SYN flood, TCP flood, UDP flood, IP spoofing, host sweep and all, in that case, my firewall going to block that particular traffic. And how you can basically check the DOS block table, this is the command debug data plane, so DOS block table. Debug data plane, so DOS block table. This is the command. Right now, we don't have anything on this particular firewall. And you can also able to remove the specific IP address. You can also do the reset for DOS block table, right? And now let's try to understand the tunnel decapsulation. So what used to happen? Tunnel decapsulation or decryption is performed at the parsing stage. Means, let's suppose your packet is belongs to the tunnel, or your packet belongs to IPsec, SSL, SHS, or GRE tunnels. In that case, your IPsec packet processing will start. What they will do? They will validate the hash. They will do the decryption, and after that, they will decapsulate. And what they will do? They will get the inner IP header. They will get the inner IP detail like layer 3, layer 4, and layer 7 detail. Now this particular detail they will forward towards the ingress processing. In case of SSL or VPN has validation happens, then decryption. GRE has validated, then decapsulated. And SHS has check and decryption. So packet is decapsulated. Discard if there is any error exists on this particular packet. Tunnel interface associated with the tunnel will be assigned to the packet as a new ingress interface. Then packet will be fed back to the parsing process, starting with the packet header defined by the tunnel type. Packet parsing for tunneled packet always start with the IP header. Just remember, means if we are receiving any type of tunneled packet, means tunnel packet means the packet which is coming towards your tunnel interface, like in case of IPsec VPN, or in case of global protect, which is your SSL VPN. What we use to create a tunnel interface. So tunnel interface packet parsing start from L3, L4 and L7. Not L7, L3 and L4. L7 parsing is not needed because all these tasks done by the Oction chip, which is not able to understand your layer 7 content. Just remember. Why in case of tunnel they will not do the parsing at layer 2? Because layer 2 is not applicable here. Just remember. Okay, these are the checks performed by the firewall in the ingress processing. In the ingress processing, these are the checks performed by the firewall. Just guys, give me one more second. If I have one diagram, actually I'm not able to get it. This one. This is the one. Because I will use this particular diagram. Guys, this is visible or not? No, it's not visible properly. I can see. Open with Chrome. Okay. Now I'll go back here. Now let's see couple of more things at the ingress stage only. the very good representation, right? No. As I have mentioned, guys, how they used to do the parsing like L2, L3, L4, check the errors, defragmentation, look up the ingress, look up the ingress zone, right? After receiving a packet. Now, IPsec or SSL, VPN, if they have received then decryption and all, right? Then they have basically do the flow lookup. So guys, see, information is not accurate anywhere. Like they have also missed here the DOS block table, right? Now let's try to understand how they will do the session match, or how they will do the fellow lookup. So guys, now just put your full attention here, because now here I am also going to add couple of new terms, maybe not that one. I was not having that diagram with me actually, so that is the reason. Let's wait here to open it properly. Meanwhile, guys, I'm audible, right? Any echo, anything? Are you able to understood this ingress stage? I know it's a bit difficult to understand in one go, but this is like that only, guys. Packet flow is a big thing. If you will understood, you can able to crack your interview easily, because these are the like SP3, then your packet flow. These are the like most important question which is asked by the ask in your interviews. This taking time. Okay, so guys, now after just once it will complete the ingress stage, so now your packet move further towards the firewall session lookup. Now when it will do the firewall session lookup, what it used to do, it will check your session table. And if you want to see the session table, this is the command show session. All this, when you will run this command, these are the couple of sessions which is available on my firewall right now. It will look for these particular sessions, okay? And how it is going to do all these things, now let's try to understand. So guys, what used to happen, as I have told you, you can see we have received this particular packet, right? After ingress stage processing, what used to happen, basically this particular packet, this firewall, this packet has the source IP, destination IP. Now tell me one thing, after ingress stage, we got the source, we get the layer 3 detail, right? Which is 10.1.1.70. We have the source IP, we have the destination IP. We have the layer 3 protocol number for TCP is 6, source port 3050, and the destination port is 80, right? And guys, if you have observed, we have the source zone as well, or not? In ingress stage, it used to do the ingress interface lookup, and it will get the associated zone detail. So ingress zone in our case is inside. Okay, so now what firewall used to do, it will take, it will basically take this source IP address detail, it will take the destination IP detail, it will take the source port detail, and it will take the destination port detail. It will take your layer 3 protocol number and source zone detail. Means these particular information is known as a 6 tuple of session. These are the 6 tuple of your session. Source IP, source port, destination IP, destination port, layer 3 protocol number, and source zone. These are the 6 tuple of session table. So what firewall used to do? Firewall basically take this particular information, and what it will do, it will just on the 6 tuple. It will basically run the MD5 hash. It will run the MD5 hash, and what it will do, it will get one hash value here, and that hash value is known as a flow key. I just mentioned flow key 1. Whatever hash value it will get here. Now, what it will do now, why using this particular flow key? Now it will use this particular flow key, and what it will do now, using this particular flow key or hash value, it will perform the lookup. It will perform the lookup into the session table, or that particular session table available in a database called MongoDB inside your Palo Alto firewall. So your session table information, or the table of the session, is created inside the MongoDB database. And it will use this particular flow key. And how that database store the information? It will store the information in the form of flow keys or in the form of hash. It will do the lookup into this particular table. And guys, tell me one thing. This is a first packet TCP SYN. Do we get any type of entry into MongoDB database for this particular session? According to you? Guys, do we able to see any information regarding this session on the session table? We will not able to see because it's a very new packet, right? And if we don't have any information, which means after performing the lookup into the session table, and we will not found the session detail, and if we will not found the session detail, then your packet go into the fast path. Sorry, your packet will go into the slow path. Means your fast path, now your packet move towards the slow path or the session setup state. And it's a new session, guys, just remember. Now let me tell you regarding this flow keys as well. Okay, just maybe just take this as a like this thing in a consideration for some time only. Let's suppose I have a simple diagram here. I have one PC here. I have a firewall here, and I have a server here. Okay, same IP address 10.1.1.70, 10.2.2.102, Ethernet 1 by 1, Ethernet 1 by 2. This interface is a part of DMZ zone, and this interface is a part of inside zone. And here we have IP address 10.1.1.250, and here I have the IP address which is 10.2.2.250. This server is listening the request on TCP port 80. Now, so guys, tell me one thing here. If I have initiated the connection from this PC initiated this connection towards this server, and this server will give the reply, right? In that case, this PC become the client machine, right? And this server become the server machine. Yes, no. This is the request packet, and this is the reply packet, right? Now, let's go here. Just take a hypothetical like this PC has initiated a connection, TCP SYN request. This request reach to this server. Now guys, when this firewall going to do the processing of TCP SYN request, right? So what it will do, it will process the packet at ingress stage. It will do the flow lookup. And guys, how it will use to do the flow lookup? It will create a flow key. And it will create this flow key on the basis of source IP address, right? Which is 10.1.1.70. Destination IP address, which is 10.2.2.102. Then source port 3050. Destination port 80. Then your layer 3 protocol number 6 for TCP. And your source zone, which is inside, right? This flow key 1 is created. Okay, and that particular flow key is also known as client to server flow key, C2S flow key, because that request initiated by the client towards the server. This is C2S. Now, once this time flow will not found, right? So it will move towards the silo path. So guys, in silo path, what it will do? It will do the lookup in, it will perform the zone protection lookup. Zone protection has been done here. Your routing lookup has been done. Your net policy evaluation has been done. And after that, your security policy checks happens. And guys, if my firewall wants to block the traffic or deny the traffic or allow the traffic, which means we have to define these actions into your security policies, right? We want to allow it or we want to deny it. So let's suppose your security policy action is allow for some time. Just think about it. We have a security policy action which is allow here. If we have a security policy action which is allowed here, what it will do now? Now what it will do? Guys, after doing the routing lookup, because destination is 10.2.2.102, why we generally perform the routing lookup? Guys, why we used to do the routing lookup? Anyone know? What is the use of this routing lookup? Why we have to perform the routing lookup? We used to do the routing lookup to find out the egress interface, because if this packet is received by the firewall is not going to store it. It will forward it, either it will drop it, right? And how firewall know he has to forward this packet through which interface? It will perform the routing lookup, right? And for 10.2.2.101, for 102, when it will do the routing lookup for this IP address, it will find out my egress interface is Ethernet 1 by 3. This interface is, guys, Ethernet 1 by 3, just remember. And once it will get the egress interface, it will also get the egress zone or not? DMZ, right? Now, if I will write down the TCP send packet details here, in TCP send what we have? We have a 10.1.1.70 as a source IP address, 10.2.2.102 as a destination IP address. Then we have a source port 3050. Then we have a destination port which is 80. Right? This is the packet received by this server. Now, guys, let's suppose now this server is trying to create a reply. Now, when this server do the reply, what is the reply? Reply is TCP SYN plus ACK. Right? Now, what is the packet format here? When it will send the reply, in reply source IP address is 10.2.2.102 and destination IP address that time is 10.1.1.70. Source port is 80 and destination port is 3050. Guys, this is the reply or not? Is this reply looks correct? No. Now guys, just put your attention here. Now let's see here. Let's do one more thing. Let's suppose when my firewall is doing the processing of TCP SYN request, it has the 10.1.1.70, which is a source IP address. It has a destination IP detail, which is 10.2.2.102. Source port detail, which is 3050, and destination port detail, which is 80. Source zone inside, and layer 3 protocol number is 6. And what it has done by looking into this information, it has created a flow key 1. This flow key is known as client to server flow key. Guys, now what happens? See, if I want to write down the information for the reply packet, then what is the source IP in the reply packet? If I want to write the information for reply packet, let me just put here, this is the request packet which is TCP SYN, and this is the reply. Source IP address in the reply is 10.2.2.101, sorry, 102. Destination IP address is 10.1.1.70. Source port 80. Destination port is 3050. Layer 3 protocol is 6, and your source zone that time is DMZ or not? Right? DMZ. Now, if you will look here, guys, when we are processing this TCP SYN request, I think while looking into this TCP SYN request content, I can easily find out the reply packet detail as well. What only I need to do, I will this source IP address I will make as a destination IP. This particular destination IP address from the reply I'll make as a source IP. Source port from the reply packet I'll make as a destination port, and destination port from the request packet I'll make as a destination port from the reply I'll make as a source port. Layer 3 protocol number is same, and this zone detail only I need to find out, and I will get the zone detail in your silo path by looking into the routing table or not. So guys, if I see I have not received this particular reply, I have not received any reply from the server, but when I will just complete my silo path, I can able to basically get the values on my reply packet. These like source IP, destination IP, source port, destination port, layer 3 protocol number, and source zone detail means for the reply packet, I will get my 6 tuple information. And guys, so what used to happen once your security policy check has been passed, and your security policy check is passed, and if traffic is allowed, what it used to do, see, my one flow key is created at that time. Now what firewall used to do, firewall create the another flow key here. It will create the another flow key here, and that particular flow key is known as a flow key 2. It is also a hash value. It will also do the MD5 hash here. And this particular flow key also known as server to client flow key. So guys, each and every session in your Palo Alto firewall have two flow keys. And guys, let me also tell you one more thing, because see, this firewall have some session capacity. Each and every firewall have a session capacity. So guys, what used to happen, all the session IDs, let's suppose this firewall have a session capacity of 2,56,000 sessions. Then all these session IDs available in a free pool. There is a one free pool available, and all your session ID is the part of free pool. So what, once your security policy check is allowed, what it will do? It will take out one flow key out of this free pool. Let's say it has take out 100 as a session ID. And what it will do, this particular 100 session ID will have two flow, client to server and server to client. Client to server flow is stored, and server to client flow is also stored in a MongoDB database by using these particular flow keys values which we have received. So guys, because see, as I have told you, like for reply packet or for subsequent request packet, my firewall will going to bypass the slow path check because it has generated these flow keys. And when it will do the session lookup, if session match is found, your packet directly jump into the fast path. It will bypass the slow path. So if you will see here, if I'll go into my firewall here, you can see I have these sessions. If I'll just look for the session ID 681, this particular value is the session ID. Sorry, session ID 681. You can see I have a two flows on my session, client to server and server to client. C to S and S to C. And I have a two flow keys. Just remember. And that particular information of these flows, it will store into the database called MongoDB. Just remember. So I hope you will understood how Firewall is going to create these flow keys. Now, the main thing come here. Guys, tell me one thing, because this is the interview question. See, let's suppose I have a TCP protocol. In TCP protocol, we have a source IP. Sorry, we have a source port and destination port field. Yes. In UDP header, we have a source port and destination port field. So, like if my firewall wants to create a flow keys, because it by end of the day it needs to find out the 6 tuple information, right? And the source IP, source port and destination port is a part of your 6 tuple information, right? And to create a session, my firewall needs this particular detail. So in case of TCP and UDP traffic, we have these fields. So firewall can able to easily handle this traffic. But about the ICMP traffic? Is your ICMP header has any of these source port and destination port field? But about your GRE traffic? But about your IPsec ESP traffic? Is these protocols have any type of source port and destination port field, guys? Tell me. Do you have seen any type of fields in your ICMP header regarding source port and destination port field? No. Do this particular test, guys. See, when you will try to initiate a ping to any website, what used to happen in case of ICMP, firewall always create a new session. Even though you are pinging the website, like you are pinging the same server, but it will create a separate session for each ping request, because in from the ICMP header there is a one field called sequence number, and there is a one more field we have in ICMP which is a identifier number or identification number. Sequence number and identification number. So guys, in each ICMP request packet, the sequence number will change. And if your sequence number will change, which means your flow will change, right? Your flow key value will change because it will consider sequence number and identification number as a source port and destination port field. Because this particular value is changing, right? For each and every packet. So that is the reason, guys. In case of ICMP header, it will use sequence number and identification number as and it will consider these values as a source port and destination port field. Just remember. And if you want to see this particular header detail, let me show you. ICMP Cloud Shark. Let's see this PCAP. You can see in ICMP header, this is the first request, right? Then we have a reply. You can see this request packet, ICMP protocol, type code. Then we have a identifier and sequence number. See? Identifier value and sequence number value. So these are the fields it will use. And if you will go here into the next request, which is this one, you can see your identifier is same, but your sequence number will change. Here we have in this packet we have a 33. In next packet we have a 34. So to create a 6-tuple information for ICMP packet, what it will use? See, source IP, destination IP, details it will get. Even the source zone and layer 3 protocol number it will get. But this value, source port and destination port field, it will not get. So it will use this identifier and sequence number value for creating this 6-tuple information. So I hope now it is clear for the ICMP packets. Guys, I hope ICMP is clear. There's a one question from Harshit. In TCP SYN plus egg, it will create another tuple. Why it will create, Harshit, another tuple for SYN plus egg message? In case of TCP, your source port and destination port field is always fixed. It will not change these values, just remember. Okay. Throughout the connection, your source port and destination port field is fixed in case of TCP. That's why TCP is a connection oriented protocol, or ICMP and UDP. ICMP protocol is a connectionless protocol. They don't maintain the connections at all. Okay. Now ESP. So they will use like identifier as a source port, or what we can do. I have to initiate a traffic to tell you the exact detail. So right now, the thing is, I don't think I have the configuration on this firewall. So interface Ethernet. So interface all. No, IP is no. Yeah, IP is there. Yeah, that's great. So what I can do, guys, now, let me just show you how it will basically do the things for. Let me just log in on my firewall. Admin at 123. ICMP. I will initiate some ICMP traffic. We can check the things live here. Okay. And one more thing, let me do that. Let me start my Chotu machine as well. That Chotu machine is in outside environment. So I will initiate a traffic. From here, we will see the SHS as well. And we will see the, and I will also take the Wireshark captures. Okay. Because if you will see these things practically, you will get more. Let me take the access of my firewall. This is firewall second. Because these are the main thing. This app ID or content ID, I will not stress much on packet flow because we have a dedicated sessions for app ID and content ID. Okay. So this is my firewall. Network tab. Just wanted to see one thing. Virtual router I'm having or not, and I have a default route as well. Yes, so which means I can able to connect. Cool. Show session all. Okay, we have just few of the sessions. Let me start my Wireshark on VMnet 1. Now I'll go into this PC. I'll just open command prompt and let me just initiate a ping 192.168.1.1 with minus. I'll just go with normal ping with 3 or 4 packets. Request timeout. VNCPH.cpl. Let me see what is the IP address I have configured here. Let me make it 70 as per our example. I know why things is not working because I don't have any rule here. Allow all. I'm just allowing all the traffic from inside to outside. Okay. On any port, anything, just allow. And I will also configure the pet rule. And these things we will see from SQLs as well. I'm just doing just to show you this practical. Outside interface is this. Any, I will go with pet configuration. Let's wait for this commit to complete. Meanwhile, guys, let's try to see the IPsec packets, okay? Because until this commit will complete, we will not able to see. So let me just show you this ESP packet. So guys, these are the Wireshark capture for ESP related packets or IPsec related packets. And what used to happen, see, we have a IPv4 header, then we have a ESP header, right? And in this ESP header, guys, if you will see, we don't have any type of source port and destination port field. Do you think any fields are there? Now then how let's suppose this ESP traffic is a pass-through traffic from my firewall. Then how firewall going to maintain the session? So for this particular process, what it will use this this SPI number. What it will use the SPI number for creating the session detail because it has this ESP number which is unique. SPI in and SPI out. These are the value it will use for this particular traffic. Just remember. And how you will get the layer 3 protocol details? You can able to see all the things here. This is your IP header. Then we have a layer 2 header, right? And here you will get all the source MAC details and other things. See? From the packet. See here you will able to see the layer 3 protocol number. Protocol number is for ESP is 50, right? These are the IPsec related packets. Now, if you want to see the GRE related packets, so just type your GRE cloud SAG, you will get the GRE related PCAPs. This is the best website where you can able to see all the PCAPs. This is ICMP for GRE. We have a IPv4 header, and layer 3 protocol number for this GRE is 47. Then we have a GRE tunnel. This is the GRE. Then inside this GRE, we have a actual IP header and the ICMP, because we have initiated the ping, right? So in case of GRE, it will use the caller ID values basically for creating the, so it will consider this caller ID value as a source IP and destination IP at source port and destination port to create a session detail. So these are the three cases basically generally you will see. Now, someone has asked how it will basically do the processing. So let me just continue without saving, and let me just initiate a ping packet from here. I have sent a 4 pings. Show session all. We just have a 1 ping request because it will use 2. Show session ID, because your ping request used to be flushed out very soon because it just have a very less timer from the session table, right? So you can see this is the client to server flow. Source port is 512 and destination port is 1792, right? And if you will go here, these are the ping requests, and just look for last request. Stop. 1792, right? So it will consider the sequence number as a destination port, and it will consider your identifier number as a source port. I hope I have answered the question, right? Who has asked? Bikram. For ESP, it will use the SPI in and SPI out values. Okay, Bikram. And for GRE, it will use the caller ID as a source port and destination port field. Just remember. And as I have mentioned, let's suppose if I will try to take the SHS access. In case of SHS, or what I can do, let me just show you one more thing. If I will initiate a continuous ping, and if I will show you the session table now, you can see we have a multiple ping connections because your sequence number value will change for each ping request. So that is the reason it will create multiple ping request, multiple sessions for ping. But if I will do here on the same PC, and if I'll open my putty browser here, if I will open putty here, or this is the software, and if I will type 192.168.1 dot, what is the IP address of this Chotu machine? User fconfig 1.9071. If you can go here, 192.168.1.71, if you will take the SHS access of this machine, accept the keys and just log in. User password is also user. And if you will see the session detail, we just have the single session for SHS. Show session ID 949. You can get the details. This is the source port, this is the destination port. And in the server to client flow, source port and destination port. Why here the value will be changed, right? Why he is not flipped? Because net is happening. In case of net, there is a little bit some difference you will see because it is maintaining the net, right? So see this IP address and this port he has translated on this IP and this port. So that is the reason, otherwise it will exactly flip the values. Just remember. Okay. And see right now total bytes count is 3110. And if I will go into the machine, if I will initiate some more traffic, let me just run here cat/etc host name cat/etc shs then sssd. Any file I can read. Right now I have initiated some traffic. Now if I will check, you can see these values will change. See, values has been changed now. So it is using just the same flow. It has not created multiple connection, but in case of ICMP, it has created because ICMP behaves differently. Okay. So now let's back to our topic, guys. So in case of GRE, it will use the caller ID. In case of ESP, it will use the SPI in and SPI out. What is in and out, I am going to cover. Okay, in your BPN classes, I will discuss how it will create this SPI in and out, what is the meaning of that and all. So the why I have discussed this information that much, because I just wanted to tell you this particular device firewall will create the session after completing your silo path. It will create a client to server and server to client flow. It will not wait for the request to come from this particular server. It will not wait for that reply. When it will send the request itself, that time only it will create that particular flow. Just remember. Okay. Because it has all the 6 tuple information to create that particular detail from the packet. Now let's discuss something. So guys, now what it used to do, when your packet received in the ingress, from the ingress stage, when your packet reached to the firewall, here firewall check the, perform the firewall flow lookup. If and how it will do the flow lookup, it will basically do the flow lookup by using the 6 tuple information extracted in the ingress stage. And what it will do, what are the 6 tuple? Your source IP, source port, destination IP, destination port, layer 3 protocol, and source zone. This is the information it will consider as a 6 tuple information. For ICMP, sequence number and identification number. For IPsec SPI, security parameter index. And for GRE, caller ID. These are the value it will use. And how it will generate the flow keys? Flow key is just a hash of 6 tuples. There is a client to server flow, one flow key, and server to client, which is the one flow key. This thing I will discuss in some time, the session state, or let's me tell you the session states as well. In your PaloAlto firewall, guys, like we have a life of a packet in PaloAlto, we do have a life of a session in inside PanOS. So guys, every session have to go through with some of the life cycle. We have a init state, we have a opening state, we have a active state, we have a discard state, we have a closing, closed, and free. These are the 7 states available in the packet. Out of these 7 stages, guys, when you will run the command show session all, you will only able to see the stable state like init, active, and discard. These are the 3 stages only you can able to see. These stages you will not able to see because these are the transient state. Okay, these are the transient state, and we are going to discuss all these stages later. Now let's go here. Now guys, what used to happen, firewall do the flow lookup, right? And because TCP SYN is a very first packet, and it will not found any type of flow. No means now, no flow lookup means no. Then it will forward this packet toward this session setup or silo path, guys. And once your packet reached into the silo path, now from here it will start the session setup related task. means it used to perform the firewall session lookup, session match found. If yes, then fast path. If no, then slow path. Or firewall session setup state. Now, guys, in the firewall session setup stage, the main checks which it will perform is the forwarding lookup. What it will do? It will do the forwarding lookup. It will do the forwarding lookup, which is known as routing lookup. Then net policy lookup, then firewall security policy lookup. And if my policy is allowing the traffic, if no, then it will discard. If yes, it is allowing. Now it will create a session and install the session into the session table, and it will store that session into the session table. Here, it will till here, it will create both the flow keys. One flow key he has created here only. The second one he will create at this stage, and after that he will install both the flow keys in the flow table by allocating the session from the free pool. This is the old diagram, guys. Now let's try to understand according to the latest one. So once packet received into the silo path, what used to happen now? In silo path, first your zone protection profile has been checked. Means your zone protection profile has been checked. And in this zone protection profile, we have a action. Either we have a action which is red, randomly drop, either we have a action discard. If your IP, if like your zone protection profile hit, means let's suppose somebody has launched the attack like SYN flood attack or UDP flood attack, and let's suppose your zone protection profile has been hit here, means now your firewall going to apply the action according to the configuration. What is the action? We have defined random only drop or discard. It will basically apply the action. Apart from this zone protection check, it will also perform the TCP state check on the packet. Guys, tell me one thing. In your TCP SYN request, can we have a SYN flag equals to 1 and EC flag equals to 1? Can we have a SYN flag equals to 1 and your reset flag equals to 1 in the very first packet? So it will check the TCP state here. What is the state here like? We are receiving the SYN or not. So it will check like flags, like SYN flag is 1 and what is the value of other flags. If we have an invalid combination, it will drop the packet right away. Now, in which case you will able to see? Let's suppose we have a SYN flag equals to 1 and EC flag equals to 1. In which case you will see this combination? Right? There is a possibility of that combination as well. So let's suppose we have a asymmetric routing environments. I have a router, I have a PC here, I have a switch here, I have a router R1 and I have a router R2. Then I have a firewall here, right? And I have a server here, let's suppose. Or let's say I have a one more router here R3 and behind this router I have a server 1. And this particular router, they also have a connectivity like this. Which means what happening when this PC is trying to send any packet to this server. So what happens? This particular traffic is going in this direction. Reach till this server. This is a TCP SYN request. Now when this server is sending the reply, this is the TCP SYN plus EC. This is the reply packet, right? In TCP SYN, we have a SYN flag equals to 1. In TCP SYN plus EC, we have a SYN flag 1 and EC flag is also 1. Let's suppose this request we have received on R3 and R3 forwarded towards the firewall. This is the asymmetric routing environment. If this is the case, what these type of packets firewall used to drop right away? If you have a asymmetric routing environment. And why it will drop the packet? Because it will do the TCP state check. By default, it will drop, but if you want, you can able to allow it. There is a way to allow it. Okay. So this is the case. So if there is a TCP state check, it will allow or deny, right? And after that, guys, what it will do, it will move further towards the user to IP cache. It will check here use IP to user mapping or user to group mapping, because firewall used to maintain the IP to user mapping and users to group mapping in a cache memory. Like there is a user ID cache. So we have a two type of user ID cache. One is a data plane and one as the management plane. So it will do the lookup into this particular check. By it will check this IP address has any type of user detail or not. And this particular check it will perform if we have enabled the user identification in your zone. In your security zone, if we have configured this user identification, then only it will check. Like if you will see here, if we have enabled this setting, then only it will perform this particular check. User to IP or user to group check, group mapping check. And guys, generally right now we don't have any mapping. Otherwise, if you will run this command, so user IP user mapping, you can press all, you can able to see the mapping. This is for data plane. For management plane, you have to type MP. Then all, you will able to see the mapping here. So these are the commands. Okay. And after that, guys, now in the latest PaloAlto, they have added the one more most important feature, which is application cache check here. What used to happen if your people, let's suppose we have a two system, PC1 and PC2. Let's suppose PC1 has accessed the Facebook just now. So for PC1, your packet will go through with the app ID and it will, your firewall identify the application. And that time firewall also used to create a application cache. And if this PC2 is trying to access the Facebook again, maybe they will get the details from here just to bypass the app ID cache. So which means we are offloading the load from the application engine. So we can get the application mapping here itself with the help of application cache, and it will create this cache on the basis of destination IP, destination port and protocol number. Just remember, it will create that cache memory with the help of destination port, destination IP and protocol number. Okay, because these are the three new things. Flow lookup we have already discussed, right? I will give you this this document. So guys, you have to read through this document. Now in slow path, as I have told you, first check it will perform, which is your zone protection profile check. It protects from the flood attacks and per packet anomaly detection. It protects network from SYN flood, UDP flood, ICMP flood, IP flood, non-IP flood, TCP scan, UDP scan, and IP spoofing attack. So these type of network attacks protection is provided by the firewall with the help of zone protection check. We can define two action like red or SYN cookies. If SYN flood settings are enabled on the zone using a zone protection profile, then TCP flood protection are triggered if the rate of SYN packets exceed the configured activate threshold. Means we have to define some threshold values to activate the connect. Means if we will get 10,000 packets per second, then activate the red threshold and start dropping the packets. We have another method called SYN cookies. So this SYN cookies, what it will do, they will firewall use to maintain each and every session detail. Like from SYN cookies, it will write the information. So this information we will discuss in your zone protection. SYN cookies is a little bit tricky to basically understand, okay, at this particular point of time. Now TCP state check, it will check the TCP state inspection is enabled, known SYN packets for the new session will be discarded. Firewall can be configured to allow non stateful TCP traffic on a per zone basis or globally even though this is not recommended, means you can able to allow this particular, you can bypass the TCP state check, means you can allow that type of non-stateful TCP traffic. And this case is happening in when you have a asymmetric routing environment or there is a asymmetric flow. And it is always recommended by the PaloAlto, you need to reject the non-SYN packets when SYN cookies are enabled, just remember. And this is the command to disable the TCP state check permanently. Run this command: set device config setting session TCP reject non-SYN no. And if you will go into this, let me run this command: set CLI config output format set. And if you want to see what is the default setting, you can run this command. So device config settings, come on. Yeah, I think you will not able to see these default settings, guys. Okay, but this is the command which you can able to try. Set device config setting session TCP reject non-SYN no. You can able to run this command. Set device config setting, press the question mark, and these are the options you can able to get here, like TCP. In TCP we have these many options: allow challenge check, asymmetric path, bypass exceed, write check timestamp, drop zero flag, strip urgent data, and all. So these are the options which are available with TCP. Set device config, why they have changed the command, looks like. So the settings session TCP reject session, then question mark. Here we have all these options with regards to session. Okay, TCP, you have a reject nonsense. So this is the command you have to type, guys. Okay, type yes or no. If you will do no, which means you have disabled this particular state check, and we have bypassed the TCP state check. Now we can run this command, we can turn on this command by using this command. We have to just put yes at the end. We can just disable the temporary as well, just to check if this traffic is dropping due to this reason. Set session TCP non-SYN. These options we can just use for the testing purpose. But if you will use this option, this command, then after reboot, this setting will gone. We can also bypass the asymmetric routing by running these particular things, these commands. Okay. User to IP mapping, it will check. Application check, it will check, guys, here. And these are the command to check what is the application status right now. If you will run this command, so running application cache, you can able to see the what is the application cache we are having. So running application cache, this is the command, and it will store the application details. What I can do, let me quickly go into this machine, into my Windows machine, and if I'll just exit out, if let's suppose I will take the access again via SHS 71. You can see it has created a mapping on the basis of destination IP, destination port, and layer 3 protocol number. It will right away put the caching. It will do the app ID cache. If you will access the YouTube, let's suppose you can try to open your browser and try to access the YouTube, you will able to see it will create the cache right away. Okay. So if I'll go here and if I'll type youtube.com, you can see it has created couple of more mappings. Okay. For YouTube related traffic. Now, so these are the command. You can disable this app ID caching, but do not disable these things. Always enable these settings. Always leave these settings as a default one, guys. Okay. Now let's try to understand the forwarding lookup. So go here. Now guys, tell me one thing. I hope this particular diagram is visible properly. Tell me one thing. Anyone have any idea about the PVF or PVR, policy based routing or policy based forwarding? Policy based routing. Anyone know what is the use of this PVR or PVF? So guys, generally PVR or PVF both are same thing. In Cisco terminology, this is known as PVR. In PaloAlto terminology, this is known as PVF. And this policy based routing or policy based forwarding we will use to basically override the routing lookups. Means your policy based routing or policy based forwarding allow us to perform the routing on the basis of source IP, destination IP, protocol numbers, and all these settings. Means we can able to now decide if source is this, destination is this, application is this, and destination port is this. This traffic will go through with Ethernet 1 by 1 or 1 by 2. Okay. So guys, now let me tell you, let's suppose you have a policy based forwarding configuration in your firewall, and we do have a routing as well, right? So what used to, when firewall do the forwarding lookup, it will always do the forwarding lookup to get the egress interface and egress zone detail. Why it will use to do the routing lookup or forwarding lookup? To just get the egress interface and the associated zone with that particular interface. So what used to happen if we have a policy based forwarding and policy based forwarding of PVF or PVR configured, or we have a routing tables, and if your traffic is matching the PVF rule, then egress interface is decided on the basis of PVF. It will bypass the routing. If your traffic is not matching the PVF, then it will fall, then your lookup is fall back to the routing, and always it will do the routed lookup on the basis of destination IP. Just remember. So if you have a destination IP this, then it will check what is the egress interface for this particular destination IP. So at layer 3, it will do the PVF and it will do the lookup into the FIB table, which is your forwarding information base, is also known as a routing table. So PVF will take high precedent, just remember here. And from the forwarding lookup, it will get the egress interface. In case of layer 2, because let's say you have configured your firewall in layer 2 mode, that time it will use the FDB lookup. It will perform the FDB lookup to get the egress interface, just remember. Okay, so after completing this routing lookup, it will move towards the next lookup, which is a net policy evaluation or net policy lookup. Here my firewall is only going to check which net rule is matching the traffic, which net rule is basically matching this particular traffic. It will just do the evaluation. It will not do any type of translation. Just remember, your net translation never performed in the slow path. Only it will do the evaluation, will identify, oh, this is the net rule, like net rule index 0, index 1, and index 2. Which net rule is matching? According to that, it will choose that net rule and it will move further. Now, guys, here we have two things. Let's suppose the matching net rule. the net rule which is matching right now, let's suppose this net rule is belongs to the destination net. So guys, what will happen in case of destination net? Your destination IP will change? Yes or no? If your destination net if your destination net rule will match, then your destination will change. But here in forwarding lookup, we will get the egress interface on the basis of destination. And now our destination is changing here. So if your net rule is matching the destination net, then what it will do, it will forward the packet again into the routing lookup to get the new egress interface according to the destination net. So this condition apply only for the destination net. Just remember. If no, now it will move further and it will basically match your authentication policies. Means it will match your user-based policies. What are the policies we have configured for our users? And according to this particular authentication policy, it will trigger the captive portal if match found. So your user-based policy is applied here, guys. Just remember. And after that, your firewall is going to check the DOS protection policies lookup. It will perform the DOS protection policy lookup, and it will do that particular lookup on the basis of pre-net IP and post-net zone for the DOS policies. Once this DOS policy match happens, now here we have some actions. In case of DOS policy, what used to happen? It will check what is the action we have defined, aggregate or classified. It will match. If your DOS policy is matching, then it will basically apply the action. If no, then it will move further. And now here your security policy lookup has been done. Means your actual security policies is matched here. Okay. Now, users pre-net IP, it will do the policy lookup on the basis of pre-net IP address, port numbers, post-net zone details. And it will consider application is any and URL category is any, and then it will match the rule. So when it will do the lookup into your SILOPA, just remember if you have configured the rules on the basis of URLs or on the basis of applications, it will consider both things here any, and it will just match the rules on the basis of source IP, destination IP, source port, destination port, protocol number, source zone, and destination zone. These are the only values it will consider here. Jinnah, this pre-net and post-net thing I will discuss in your net class. Okay. So here you have to just remember what is this. It will do the lookup on the basis of pre-net IP address and the port numbers. Okay. Now, it will basically, whatever the rule is matching, it will start checking all the rules from top to bottom. And if whatever rule is match, if action is allowed, which means it will move further. If action is denied, it will discard the packet right away. It will discard the packet right away. And once if your traffic is allowed by the security policy, now it will create and install the session into the flow table and other information into the session table. Means it will now create a two flows, server to client and client to server, where we have a source IP, source port, destination IP, destination port, protocol number, and source zone. In server to client, we have a source IP, source port, destination IP, port, protocol, and source zone. This information it will basically store into the session table. And guys, after it will also move further, it will check your TCI related policy, which is your tunnel inspection policy. If you have heard the name of guys this cryptocurrency and all, right? People are using this cryptocurrency, and you heard the name of they used to perform the 7-layer encryption, right? Which means your packet is encapsulated inside the 7 layers. So now they will check for these type of layers only. Firewall is also going to check for these type of layers. If your how many tunnels you are having, what is the exact information inside these tunnels by using the TCI policies. And my firewall is only able to look for the maximum of 4 tunnels. It will not able to look more than that. If everything is yes, then it will move further towards your, now it will basically move the cursor towards your flow state in the session table. And now it will check, like it will, what it will do now, in the flow table it will install the session. If session state is free or discard, it will discard the packet right away. If your session state is opening, active or discard, it will reset the TTL value, time to live value of the session, and it will move further towards the security processing, which is your fast path. So now after slow path, your packet come into the fast path, which is here. Security processing, which is fast path. Okay. Now let's go here. So I am not going in attachment, like I have written everything here as well. So you can able to check how it will do the things and all, because all the information I have already put. Now your packet moved towards the fast path right here. Now in fast path, what it used to do generally, it will start the packet processing again from layer 2 to layer 4. Now on which packet this particular processing applicable? This packet processing is applicable for the packet which is directly jump into the fast path from flow lookup stage for the existing packets. And guys, your net translation is applied here. Whatever net rule is measured in slow path, now here it will perform the net translation. Your actual IP translation is happening here. Mohammed Tabriz, if your session is in discard state, then this session has been discarded by the firewall. It will not come here. I think you have not seen my cursor here properly. If your session state is discard, then it will directly jump into the drop state. Your session come into the first path if it is in opening, active state only. Opening state or active state. Because if a state of your session is discard, then it will check here before checking your time to live. It will discard right away. Here it will move only the packet which is active or in opening state. Now here it will apply the net if net translation is applicable. Now move further. It will again do the forwarding lookup for all client to server and server to client packets. Now guys, why it needs to do the forwarding lookup again into the fast path? It will do this particular lookup for the for upcoming reply and request packets. Whatever upcoming request and reply packet we will see, like send plus ACK packet, then ACK packet, then your HTTP get request, post request and all. For them, it will perform the forwarding lookup again in your fast path. If there is no route found for these packets or there is a zone change, it will discard the packet right away. And this particular thing is also helpful. Let's suppose you have just changed the routing. You have changed the routing right now, and there are a couple of existing sessions will be there. And if there is a zone change or there is a route change, what will happen? Your packet is discarded right away. Then it will move further and it will check for the SSL proxy. Now here your SSL decryption is applicable. SSL proxy flag in session, if SSL proxy session, like if your packet is going through the SSL proxy or SSL decryption, there is a one flag, which is a proxy flag, which is associated with that particular session. If that particular flag is there, then the packet is basically go for the SSL decryption. And that time, all the layer 7 information from that packet is given to your SSL engine. We have seen yesterday dedicated SSL chip. That particular chip get all that layers of information. It will start doing the decryption and all. Apply the decryption if applicable. And move further, it will check application identification in the session. If application is identified, then your packet move towards the CTD. If no, then your packet move towards the app ID. Okay. Now when this, see, because it's a new packet, so we don't have any type, like application is not identified, right? So what it will do? It will now move into your application engine. Okay. Now in app ID, what it will use to do? Once your packet reached into the app engine, it will check the app override policies. If we have configured the app override policy to bypass the app engine, if yes, then go here. It will basically security policy lookup based on the application. If app override policy is not matching, then it will do the application identification on the basis of patterns. If now here it will perform the security policies on the basis of that application. If no, then it will discard the packet. Means if your policy is allowing, let's say we have a deny rule for Facebook, it will drop the packet right away here in your app identification stage. Otherwise, your packet move further and they will do go for the content inspection. If let's suppose your application identified as a SSL here, now my firewall will check, do I have a SSL decryption enabled or not? If SSL decryption is enabled, now firewall forward this packet for the SSL decryption as well, and will give that information to, it will send back that information again to first path for the SSL decryption. If we have configured the content inspection, then your packet go towards the content inspection, where they will first check the application script. They will basically use the protocol decoder, parser and all to basically try to get if there is any type of malicious traffic available on the packet. If that they have some malicious traffic, they will basically drop the packet right away. And now if SSL decryption is applied, then they will re-encrypt the packet and your packet go into the forwarding stage. Now in forwarding stage, what they will do the packet forwarding process, use the Ingress interface to get the forwarding domain, do the route lookup, switch, vwire forwarding and all. And if QoS is applied, then perform the quality of shaping. Fragmentation is applicable, then they will do the fragmentation. Here they will perform your L3 and L2 lookup, like your ARP lookup. They will create the IP header and all these particular things. If packet belongs to IPsec VPN, then they will do the encryption and all. They will do the encapsulation and everything. And after that, your packet send out towards the into the wire through the egress interface. So guys, that's how the PaloAlto firewall going to the packet processing. Go through with this diagram, read each and every point here. This document, I will share this document with all of you. Now guys, see, I have just go through with this particular things, okay, because you know app ID and content ID I'm going to cover in detail in your app ID and content ID session. So that is the reason I have not go in that much depth here. Let's just see the egress stage finally. Packet forwarding processing, use ingress interface to get the forwarding domain, do route, switch and vwire and forwarding, right? Packet ingress process, IP fragmentation applicable, apply QoS. In case of VPN traffic for IPsec, ESP, SSL, GRE, they will do the encryption, has added and encapsulated, encrypted, has added, then encapsulated, and after that he has forwarded the packet through the wire. So that's the final. No, they are not doing the next hop lookup. They will do the ARP lookup, Muhammad. Okay, ARP lookup is performed at the end only when your packet is going out. Now, let me just show you this thing as well so you will understood how the packet processing used to happen, guys. So generally, if you will see, when we receive a packet, always packet is put into the ingress stage processing, parsing, and all these things has been completed, and after it they will perform the flow lookup, which is the next check, right? They will do the flow lookup, and you can see session setup. This no active flow found. In queue to create a session means, see, if there is a session, then they will go into the fast path. If no, there is no session, then it will in queue this packet towards the session setup state to create a in queue to create a session. Now your packet received into the slow path stage. In slow path, it will perform the PVF lookup, session setup, net policy lookup, destination net translation, PVF, session setup, translated IP address, right? It will perform all these in TCA inspect, scanning, right? Policy lookup, matched rule index, this and all. Allocated the new session ID, right? They have allocated the new session ID, right? Then destination translation is like that. They have created a session and in queue to install this session into the session table. And after that, your packet come into the fast path stage. IP check some validation, right? Net session, now here they will do the actual translation. And after that, they are doing the, by end of that, they are doing the forwarding lookup, and they are sending the like L3 mode, router this, route lookup, route found, resolve ARP entry found, transmit packet into the wire. So that's how the packet processing. Now for simplest sec, we have received an ingress stage. This time when it do the flow lookup, he has found the active flow, receive packet in fast path directly. It has just bypassed the slow path completely. For TCP ACK packet processing, we have received the packet in ingress stage. Active flow has been found in fast path. So that's how they are going to do the packet processing, guys. Now this is for SHS related packets. Here also you will not see app ID related thing because I have just taken the flow basic log, not at the app ID level. Okay. Now what we have here, see here, he is just writing the information, man. Here he is not performing the route lookup coverage. Why you are not trying to understand this point, right? You have to believe me, man. Otherwise you will not get anything. Okay. These are just a log, and here what it is doing, when he has performed these route lookup into the slow path, he is just checking these information. That's it. He's just showing these logs here at the forwarding stage. Okay. It will not do the route lookup at the end. Just remember. Now, one more thing, guys. Let me just show you. And after that, I'll just bind this session. So we have around, yeah, we have some time here. So let me go into this. So guys, as I have discussed, we have a life of a session, right? So let me tell you, in most of the time when you will see your session is in a init state, either in active state or either in discard state. Your opening state, free, closed or closing. These particular states you will not able to see in your session table when you will run the command called show session info or show session all. Okay. This init state you will see, let's suppose you have received a very first packet, right? And now you're after doing this flow lookup, your packet is go into the slow path. So during that particular period of time in the slow path, your session is in init state. When in your slow path, when your packet, let's suppose your packet is denied by the security policies, then you will see the state which is discard. If your packet is allowed by the firewall, and now when your session is finally installed into the session table, that time you will see the state which is active. Discard state you will also see if your session is dropped by the app engine, by the application based policies. If your traffic having any type of malicious content, which means that time your content engine will basically discard that type of traffic, that time your session state will be in discard basically. Okay. And like in your slow path, after from initialize, and it means initializing state, your session go in a opening state. Then active state. Now from active, either your session go in a discard or closing state. This closing state comes because every session has a timeout value. Like we have a TCP timeout, TCP connection timeout values. We have a UDP connection timeout values. We have a ICMP connection timeout values, right? So according to these values, it will go in a closing state, then close state, and after that your session will go in a free state, means it will, that session ID will go back to the session table. And if when you will run this command show session info, you can see this is the detail, guys. If you will see here on my PaloAlto firewall, I have a data plane 0, and this particular data plane 0 support around 8,19,200 sessions. What is the allocated session? Right now, 6 session is allocated. What are the TCP connections? There is a 1 TCP connection. There are 5 UDP connections, 0 ICMP, 0 GTPC, 0 STTPS, GTPU 0, right? Broadcast, multicast, predict session is also 0. SCTP is also 0. SCTP association is 0, right? And session table utilization is almost 0%. Number of session created since last boot up is 2,735 packet per rate, 322 packets per second. This is the throughput in kbps, right? And new connection per second is 0 right now. And after that, if you will go here, now these are the timeout values, guys. So the default timeout value for TCP connection is 1 hours. Means if your TCP connection, like somebody has sent the TCP SYN, we have received SYN plus ACK, then we have sent the ACK and he has sent HTTP GET request. Now response, for response he is just waiting. So what now the TCP connection has one, or TCP connection session timeout is like session is created. Now you can keep this session in ideal state for 1 hour, 3,600 seconds. TCP session timeout before SYN plus ACK received, means let's say we have sent the TCP SYN request. NAB will get the SYN plus ACK message within 5 seconds. Then in that case, firewall basically accept that request. Otherwise, firewall basically remove that particular connection from the session table, and it will drop the SYN plus ACK packets. Means after sending the TCP SYN request, firewall wait only for 5 seconds to see the SYN plus ACK for this particular session. Otherwise, session detail has been removed from the firewall. TCP session timeout before three-way handshake means 10 seconds. Means your guys TCP three-way handshake process will complete within 5 seconds. TCP half closed timeout. This is the half closed timeout. Means there is a communication is happening between client and server. This client had sent some data. This is how their communication. Let's suppose this server has sent one message called FIN. One packet will FIN request, but client still wants to send some more data. And after let's client had sent this data, he has got the ECK. Then client send FIN plus ECK. Then they will get the ECK. So which means during this state, right? Because of that issue, because sometimes what used to happen if one end send the FIN request, in previously what used to happen, that type of session is used to close right away. So now they have basically put the timeout value, which is 120 seconds. Means after getting the FIN request, this client can send the data till 120 seconds. Okay. Now TCP session timeout. See, TCP session timeout in time based state. This is the time based state, guys. TCP session delay ACK means it will wait for the delayed acknowledgement till 250 milliseconds. TCP session timeout for unverified resets. If we are getting the unverified reset, then 30 seconds. UDP default timer is 30 seconds. ICMP default timer is 6 seconds. SCTP default timer is 1 hour. Right, then we have a other IP default timer is 30 seconds. Captive porter session timeout is also 30 seconds and all, right? So these are the timeout details with regards to each and every sessions. Then we have a session acceleration aging process as well in your PaloAlto firewall, which means, so guys, TCP connections have a default timer which is 1 hour, right? Let's suppose your session capacity, let's say your firewall able to accept around, it has a capacity of 10,000 sessions it can able to accept only. Mean this is the maximum capacity of your PaloAlto, which is 10,000 sessions. Let's suppose around 8,000 sessions is already created. Means your 80% utilization is already there with regards to your session table. So in that situation, what used to happen, there is a one process called session acceleration aging. This particular process will start to basically kill the unused or unnecessary sessions. This value is by default true, and this particular process is just used for the optimization, the session capacity in the PaloAlto firewall. What it will do, it will basically reduce the timeout value with the scaling factor by 2. Means if your TCP connection timeout is default is 3600 seconds, it will divide by 2. That time your session capacity become, or session timeout become the 800 seconds basically. This is the timeout value, TTL value. This is was like non-TCP rejection is true, like it will drop all these type of connections as well. So all these is the basically details available with regards to your sessions in your session table. Okay guys, so this is the information only which I want to discuss with regards to your today's class. I think we are good to wrap up.